Well, welcome. In this video, we're going to be looking at how to put everything we've looked at so far in this chapter to determining what would be a best model to use to fit a set of data. So we're going to be looking at a lot of things that we've done in the calculator, a lot of the things that we've talked about in class to be able to make those determinations. So first, let's review about what it means for a correlation coefficient, because a correlation coefficient is a tool that we could use to figure out whether or not the model that we're looking at is a good model to use. However, a correlation coefficient is only good or only can be used when we're looking at a linear model. It can't be used for the other models. It's not possible to find the correlation coefficient. It only applies to linear regressions or linear models. So there's got to be a better tool that we could use. And we looked at that tool in the previous video, and we've talked about it in the past, and that's looking at the residuals. Remember, the residuals can be found by taking the observed minus the predicted. It's always in that order. You always take the observed minus the predicted. Doing so will give you the residual value. And we can do something that's going to be shown here to be able to look at the residual plot. And so let's look at an example now where we'll look at some visual residuals. But then we're also going to be looking at an example that we talked about in the previous video dealing with the song length and the amount of songs you could fit with that song length on a 32 gigabyte MP3 player. And we're going to try to figure out what is the best model to use in that scenario. So let's go ahead and let's look now at a residual plot that we've already talked about, but just to review that, and then let's look at a specific example so we can figure out what is the best model to use in that scenario. Okay, so here we have a graph that they fit a linear regression over that scatter plot, and they gave us the residual plot. Now again, what this is saying is that a residual plot compares each x value from the data set with its residual. If the residuals are clustered around the x-axis, the model is likely a good model for the data, because what the x-axis represents here is when the observed value and the predicted value are 0, they would be right on that x-axis. So in other words, when they are on that line, that means that it's right on. So if it's really close to that line, that means it's a pretty good model. So this one here, we can look and see that it's a good model to use because most of these points are close to that x-axis. Let's look at some of these other examples where we have some, these are some residual plots, and it's important to see that these are residual plots. These are not scatter plots. So when we look at this, we want to see, are they clustered around that x-axis? And this first one is clustered around that x-axis, so it is a good model. And then let's look at the next one. The next one is a weak model. The reason why is, even though you might think, well, that looks like a parabola, and it's pretty, if I drew a line of best fit here, it looks like it would be pretty close to that line. But remember, we're not looking at a scatter plot. We're looking at a residual plot. So the fact that all of these are so far away from the x-axis tells me that this is a really weak model, because what these numbers would represent is the fact that since those numbers are above the x-axis, that means that our observed value for those points are a lot more than our predicted value. So if you were to take the observed minus the predicted value, you'd get a large positive number, and that's what's going on here. And same thing with this one. This would also be a weak model because we have these points that are pretty far away from the x-axis, both above and below it. So that would also be a weak one. Now, we're going to be looking at this example, and if you print out my notes online, you'll see that there's a lot of steps here. And these steps aren't meant to be overwhelming, but we're going to be going through each of these steps individually so you can see how to do it. But basically what we're going to be looking at is we're going to be looking at this example that we did in the previous video where we were comparing the average song size with the number of songs that could fit of that song size on a 32 gigabyte MP3 player. Now, in the previous video, we found that the model that we were using was not exactly the best model. And maybe there's a better model that we could find. And this is the model that we were looking at. So we're going to go back and we're going to plot these points into our calculator. And then after we get done plotting those, we're going to create a scatter plot, and we're going to go back and look at that model that we looked at in the previous video for the 31,850 divided by x. And then we're going to look to see if we can find a better model that would fit that data. So why don't you guys go ahead, get out your graphing calculators or your TI-nspires, and put these points into a table. But let's be consistent here. We're going to use A and N as our column titles. So we'll have the first column, column A, we'll also call that lowercase a to represent the average song size. Column B, let's represent that with the letter N to represent the approximate number of songs that would fit on the MP3 player. So go ahead, pause this video when you have these numbers plugged into your calculator, and hit play when you're ready to move on to the next step. Okay, so you should have plugged these numbers into your calculator, as I've already done here. And now we're going to create a scatter plot. So we are going to go to click the home button, go to this histogram to create a scatter plot. Remember to hit the tab button, and we can just choose A for the x-axis, and we're going to choose N as our y-axis. Now recall again that we have that equation that we talked about on Friday that we're going to plot over the top of these points. And that equation was 31,850 divided by x. And right now we're on step 2 if you're following along in that activity sheet. So what we're going to do is we're going to go to Menu, and then we're going to go to Analyze, and then number 4, Plot Function. And we're going to type in the equation 31,850 divided by x. And when you hit Enter, it looks like it goes through a few of those points. It looks like it might be a good model. I mean, we can see that this one out here is kind of out on its own, but otherwise, for the most part, it looks like it's a pretty good model. Well, let's look at the residuals to really see if this is a good model to use. So if you go to Menu, Analyze, Residuals, Show Residual Plot. So remember, this line here represents if any points that are right on that line, that means that the observed and the predicted are really close together. And the closer they are to that line tells us that they're going to be closer to, or it's going to be a better fit model. So we can see that this one out here, though, has a residual of negative 847. And the fact that that's negative 847 tells us that these points here, even though they look close to that regression line, or that line there to represent our residuals, that one there is 223 units off. So that means that the observed is 223 units more than our predicted for that one. Even this one looks like it's pretty close. That's 122. The observed is 122 units more than our predicted. Well, let's see if we can find a better model. So what we're going to do is we're going to create another scatter plot. Now, the nice thing is we already have the data put into our table. Whoops, I don't want to do that. So what we want to do is you actually want to go to another graphing screen like this to create a scatter plot. So we're going to do Tab, put A again on their x-axis, hit Tab again, put N on our y-axis. And now we're going to use exponential regression. So do Menu, Analyze, Regression. Exponential is number 8. And this one, it looks like it goes through more of the center of these points. You see that we have some above it, and we have, what, 4 of them above it and 4 of them below it. That's a pretty good line. But let's look at the residuals and see how good it really is. So we do Menu, Analyze, Residuals, Show Residual Plot. So again, you can see that they're relatively clustered around that line. Let's see if we can get it even better. Let's do a linear regression. So again, we're going to go to the Home button, go to a scatter plot, plot these points along the x-axis for A, put the y-axis up on the, or put N on the y-axis, and again, we're going to do linear regression, the mx plus b one, so Analyze, Regression, show the first one, so linear. Okay, so what you're going to want to do is you're going to want to write down these equations that we came up with here. I forgot to tell you that in the previous one. So, but first, let's get the residuals up. But what you're going to want to do is on your sheet, if you're following along on the activity sheet, you're going to want to fill this in steps 5 and 6, or if you're just following along on your own, write down these equations. So this would be the linear equation, because we're going to come back and use these later. So y equals negative 1,233.74 times x plus 12,678.11. And then we can look at this one here. So again, write this down if you're following along in my worksheet. Put this in for step 5 for your exponential regression. This would be y equals 16,132.95 times 0.83 to the x power. Now, to be able to go back and forth between these different screens, you're going to hit Control left and Control right. So I want you to kind of cycle through your screen If you don't have a calculator right now, you can be looking at mine. But I want you to cycle through your screen between these different graphs. So here is the linear equation. And be focusing right now on the graph of the residuals down on the bottom part of the screen. So there's the linear model. This would be the exponential model. And this was the inverse variation model that we started with. So I want you to take a second and cycle through those. And I want you on your own to figure out which one you think is the best model based on those residuals. So maybe you thought it was the first one. Because at first glance, I probably would have thought the same thing. However, you need to dig a little deeper. You need to be a little bit more observant if you're just looking at when we're looking at these residuals. Because not only what do we want to see are they clustered around that line, but we want to see what is the range. So over here, the fact that our range is dealing with that going up to 600 and negative 600 tells me that this point down here that's negative 850 is kind of skewing our information here, because it's almost like we're really zoomed out, so in that way we can see that point. And if you're zoomed out, it's going to at first appear that those points are closer to that to our x-axis. Because let's look at the next one. This one here now has a range of negative 300. If we look at some of these points, they're not as far away as the other one. So this one here, even though it looks like it's far away, it's only about 170 as opposed to in the 200s for the previous one. This one here, that's close. That's only off where observed is 48 points less than the predicted. So this one here looks like it's actually a little better model than the previous one. Let's look at the linear model. Here you can see your range is negative 250. So again, this point here is 86 points off. This is 22 points off. This one's 73 units off. So this one here actually looks like it might be a better model because it is, since our range of values are smaller. Now you might think, well, how would I know though between the last two, between the exponential and the linear, how could I know for sure that the linear model or maybe the exponential model would be the best model? Well, to do that, we're going to be looking at the sum of the squared residuals. So if you're following along, we're now on step 7, which is going to be on the back side of that activity sheet. So to be able to figure out what the sum of the squared residuals is going to be, we're going to go back to our spreadsheet. So to do that, just hit Control and then left a couple of times until we get back to the spreadsheet. Now we're going to go up to column C, and in that cell for column C, we're going to call this column PRED for predicted. And then go down to the first cell in that column, not the gray cell, but the first, so cell C1, so next to the 8,000. And we're going to type in our equation that we're going to use. We're going to start out with the inverse variation model that we came up with in the previous video, the 31,850 divided by x. So we're going to use that as our equation to come up with our predicted values. So we're going to type in the equal sign to tell our calculator that we're using a formula. Type in the 31,850 and divided by, but we're not going to divide by x. We're going to put column A, those numbers in for x. So we're going to compare with our observed values, which are column B. So I'm going to type in here A1. Notice how it does it in italics. It does that to tell us that we're referring to the cell. So hit enter. And you should have 8,847.22, or if your calculator rounded, you may just see 8,847, which is fine. Now I don't want to type in that formula every single time. So I'm going to go back up to that first cell, and I'm going to copy and fill this down. We're now on step 10. So if you want to see on step 10 how to do this, that'll tell you what to do. But we're going to do menu, data, fill, and now we're going to arrow down until we get to the last piece in our table, which is going to be down here at the 8th one, so the 6,300, and just hit enter. And when you do that, it automatically fills in that equation for each of those values in column A. So now we found our predicted values. Now we're going to figure out our residuals. So we are on step 11 now. So we're going to go up to column D. And we're going to call this column D RESID for residual. And now what we're going to do is we're going to go to that first cell, make sure you're in D1, and we're going to type in our equation. To find the residuals, it's always the observed minus the predicted. Our observed is numbers in column B. Our predicted are obviously the ones we just found. So what I'm going to do here is I want to take the 8,000 minus the 8,847.22. But to do that, I'm going to use the cell references. So I'm going to type in equals, don't forget the equals, B1 minus C1, and hit enter. So you should get negative 847 or negative 847.22. Now we're going to fill this down just like we did in step 10. So right now we're on step 12. Go up here, do menu, data, fill, and then we're going to arrow down till we get to that last column, hit enter, and it should have filled that in for us. Now, we're going to go up to column E. Remember, our goal here is to figure out what the sum of the squared residuals are. So in this column, I'm going to type, instead of typing in squared residuals, we're going to type in SQ and then RESID. Make sure you're in column 1. There we are. Now we're in column, or cell 1 for column E. So in this equation, or in this cell, we're going to type in the equation equals. So we want to take the square of the previous answers for our residuals. So I'm going to take and type in equals D1 squared and hit enter. And we'll fill that down just like we did in step 10. So menu, data, fill, arrow down, whoops, went too far, and hit enter. So now I want to figure out what is the sum of that column. What is the sum of my squared residuals? So to do that, we're going to go to a calculator screen. So hit the home button. Don't use a scratch pad. Go down here to the calculator on the bottom. And we're going to type in the phrase SUM to tell the calculator we're finding the sum. In parentheses, we're going to type in what column we're trying to find the sum of. So SQRESID. Notice it goes bold, indicating that we're referring to a column title. Hit enter, and the sum of the squared residuals would be 787,005 if it rounded, or 787,004.9. Now, we want to find the sum of the squared residuals for the other two scenarios, for our exponential regression and our linear regression. Now, the good news is it's a lot less work than what we just did. So go back to that table, so hit Control left, arrow over so you get to, in column C, cell 1, and delete the cell. And if you notice, as soon as you delete the cell, everything in that row from there on disappeared. And you have like little dashes there saying that we need to put something in. So we're going to put in our equation now for the exponential regression. So we're going to type in equals. Then the equation was 16,132.95. So 16,132.95 times, in parentheses, 0.83 to the x power. But this time we're not going to use an x as our exponent. We're going to refer to a1 as our exponent. So type in a1 and hit enter. And you'll notice that as soon as you hit enter, everything to the right automatically filled in here. So we don't have to retype in any of those equations. But nothing below cell C1 changed, so I have to apply this new formula to all those other cells. So go to menu, data, fill, and let's go down to the bottom and hit enter. You'll notice that the other cells also changed as soon as you hit enter. Now, do not hit the home button and go to a new calculator screen. Hit Control, right arrow to go back to the other calculator screen that we already were at. Hit the up arrow 2 times. And what that does is that selects what we typed in before, because I don't want to have to sit here and type the sum of the squared residuals again. So hit the up arrow twice so it selects it, hit enter, and it pastes it for us in a new spot. Hit enter again, and we find the sum of the squared residuals. So now I have an actual number I can look at to see that, yes, this is definitely a better model because it has a smaller sum of the squared residuals. Now this is for our regression line. Let's determine now what the sum of the squared residuals would be for our linear equation. So again, hit Control left, go back up, repeat this process now by going up to C1, delete that cell, type in our equation now. don't forget the equal sign, and then type in the equation, negative 1,233.74 times, but instead of times x, it's going to be times a1, because that's the where we're going to put those values in is for x, and then plus 12,678.11, and hit enter. And again, you'll see that it automatically fills into the right there. We're going to copy that value or that equation down now, so you go back up to it and hit menu, data, fill, arrow down, and hit enter. Again, you see that they automatically changed everything to the right there. So now we're going to go to our calculator screen. So go control, right arrow, hit the up arrow twice, hit enter. It copies and pastes it. Hit enter again. And now we have 144,698. So again, we have a concrete number to be able to compare these different sum of the squared residuals to see what was the best model. Let's look back at those graphs. And again, this whole part that we just did to find the sum of the squared residuals just reinforces the point that by looking at the range, you can tell whether or not the residual graph is a good one as we compare some different models. Because you can see that this one has a smaller range, so that means the sum of the squared residuals is going to be smaller for this one. Our linear equation, though, had a even smaller range. So that tells us that this one here would have the smallest sum of the squared residuals. So this is the best model to use. So I know that was a long video. That was a lot there as far as how to use your calculator. But the key is to make sure that we understand how to compare these different models to figure out what is the best one. Because in the real world, this is oftentimes what people's jobs are consisting of, trying to figure out what's the best model to use, because then once we determine the best model, we can use that model to be able to make predictions, whether they're predictions dealing with extrapolation or interpolation. But for this case, this would be the best model that we'd want to use for this scenario. So with that, now good luck as you do the problems in your assignment.